All right. So today we are talking about two pretty big concepts and related concepts in object-oriented programming, inheritance and polymorphism. And along with this, we're also going to talk about composition, which is really a design approach or sort of like a design pattern, more of a design strategy that you can use with object-oriented programming. Inheritance in particular is also a really fundamental concept in object-oriented programming and pretty much every object-oriented programming language, including Python. So inheritance is both a language feature and it is also a design approach for how we can design our programs in good ways. So we're going to talk about when and why to use inheritance, how we can use it to help kind of level up our code, follow the dry principle of don't repeat yourself and have our code be modular and encapsulated. We're also going to talk about how not to use inheritance that can make code difficult to read and maintain. When we dig into inheritance, we'll be learning about child and parent relationships between classes and the super method. Instance versus class methods, we actually covered that yesterday, so this slide deck just needs to be updated. We'll talk a little bit about multiple inheritance. I'm going to save that to the end, I think, because it's a little more complicated and it's also less used. And we're also going to talk about this design strategy, really, of composition versus inheritance. And just like with everything else we're covering this week, this stuff will show up on the assessment. And this is all really valuable stuff to be learning. So what is inheritance? We've learned about classes, and we can imagine if I wanted to write a program to sort of model or simulate a phone, I would make a class named phone. Well, I've got iPhones, and if any of us are still using them, though they're pretty cool, I have to say, the Nokia candy bar phones and the Motorola flip phones. So there's a lot of different kinds of phones, right? So inheritance lets me create an iPhone class that inherits from the phone class. Because all of these phones, the iPhone does a lot more, but they all basically do the same thing, right? You can make a phone call, you can save people's contact information in the phone. There are things common to all these phones. And so inheriting a class, like a phone class into an iPhone class, or a flip phone class, or a Nokia phone class, lets us, not repeat code, make it more modular, make sort of our interfaces more consistent, and put all the logic for what all of our phones are going to do in one spot. A bit later, we'll also be talking about polymorphism, which is a related concept, which is where we might have different tools like Google Meet or Zoom or Skype, and they're all video chat tools, but they do all kind of work in different ways. So just the same way we can do a video chat, but the video chat happens in a different way or with a different tool, we'll see how with polymorphism, we can have related kinds of behavior that are not the same, which I think is a good way to say it. And we'll see polymorphism in action a bit later. So that's sort of the overview of the plan for today. And I'm just going to dive into writing some code. And we have the curriculum over here, but we'll have that off to the side. And any questions before we dive in and get started? Okay, awesome. And I am going to pull up the X-ray questions channel. And I'll be checking that as we go, and I'll do my best to keep an eye on the participants list. And apologies in advance, I need to get an additional external monitor set up so I can have the Zoom grid up as well. I'm doing a little, I've got my two monitors, but I need the third, so I'm doing a little more window hopping than I would like at the moment. So apologies in advance if I get confused. So we're going to look at inheritance, we're going to see how to keep our code dry with inheritance. And as I said, we'll talk about composition, polymorphism, and some abstract methods. And we're going to start by doing what we know and creating a couple classes. And we're going to do this with some dogs and cats and pets. I'm going to go ahead and I'm going to make a directory named animals. And I think inside animals, I'm gonna make let's start with making a dog class because that's a great pet, right? We'll do dogs and then we'll do cats. And actually, could someone help me out with this? And maybe guide me through creating this dog class? I know I want to start with this. What do I want to do next?
Initiate the init,
Yeah,
and
we
we
need a dunder init method.
then the init method and self, and give the dog the parameter that will describe the property. Sorry,
Yeah,
like
exactly.
like sound,
Yeah, dog
like
sound.
breed.
Breed is a good one. I'll put breed for sound. What
Yeah,
else? What else do we want to give our dog?
color.
Color. Color is a good one.
Yeah, that's enough.
I'll throw in
Yeah.
name and I'll throw in, just for fun, I'll throw in age. Awesome. Okay, and can someone else help me now? Now that we know that, hey, I'm gonna make a dog named Rover, right? Rover and Rover will be a Labrador. Rover will bark. Rover will be 3. What do I need to do next so that now that when I create this class, stuff actually happens?
Use self, so self.name, self.breed, and then
Yeah, totally. I have to assign the arguments I pass into the dunder init method to instance attributes. And we probably don't need getters and setters for most of these, but just for fun, can someone walk me through maybe making a getter and setter for age?
Yeah, just we're gonna make underscore and age. No.
Oh, thank
No.
you. You're
Yeah,
totally
you're
right.
welcome.
My apologies.
Thank you.
Yep. And now how do I write my getter and my setter for age?
You would do at property. I believe you have to define it as well. So define get underscore age.
Yep.
And then I believe it return self dot underscore age
You
equals
got
get.
it. Awesome. And how about the setter?
I believe it's you have to name it. So we have get age, so we have to do get age dot setter.
Yep, exactly. This decorator needs to be the name of our getter method and then dot setter. Yep. And
then
take
you
us
have to
home.
define it again. So you have to do define get set. Oh, set age. Okay. And then you have to put the arguments. So self, comma, get age.
Well, let's name this argument new age. Just I think you're on the right path, but when we pass in this argument, I'll call it new age. And then I think, what do I want to do here?
We want to make sure that the age is an int.
Yeah, I love it. If type new age is int, then what?
Then return new age, right?
Close. We can return new age, but does this update? What's the what? This
Then we
is
can,
the instance attribute that keeps track of the age, right? So I want my set age setter to update this value.
So it's gonna be plus equal.
Well, if I did plus equal, it would add the two ages together. But if I just want to say change my dog's age from 3 to 4 or 12, I can just do it like this. And that was awesome, guys, and that's why I wanted to do just a little review and warm up with this as well. And so just to recap, for a getter and setter, we have an instance attribute, in this case, let's say age, and we don't want other programmers to interact with it directly. So I name it starting with an underscore to indicate to other programmers that this should be accessed through the getter and setter for it, which Python calls properties. And we make a getter using this property decorator. And I'm just following the get age, set age naming convention because that's what we have in our curriculum. And this one just returns self dot underscore age. And then to change it, because for age, I don't want to increment it. I just want to set it to whatever the new value is. I need to take in the new age as an argument. I love checking that it's an integer. And then we set this underscore age value to be our new age. And that way, the next time I do get age, we see the dog's new age, right? Because here, if I do rover.get age, that should give me 3. And now if I do it here, it should give me 12. And let's go ahead and run our code real fast to make sure that this is correct. Actually, let me go into the animals directory and let's do Python dog.py. And it looks like I'm missing an argument, which is why it's always a good idea to run your code. And let's see, name, breed, color. Color. Thank you so much. And it will be a yellow lab. Right, because if I look at this, my error message tells me this init method, it's missing a positional argument, and it tells me it's happening on line 18. And Python tries to kind of figure out which argument is missing. It thinks age is missing, but that's just because I don't have enough, right? I only had 1, 2, 3, 4 arguments, and so Python stuck them in order 1, 2, 3, 4, and age was not getting anything. And now if I run this again, fingers crossed, we're good to go, and we've updated Rover's age. Okay, awesome. Let's go ahead, let's make a cat. And I think what I'm gonna do is I'm gonna make a file, yeah, let's make another file named cat. So let's just do cat.py. And let me do a split. I think a split is the way to go here. And we'll push that off to the side. I'll close this out for now. By the way, if you do Command P on Mac, or I think it's Control P on Windows, it opens up a sort of file searcher that you can very quickly open files in. And let's go ahead and make a cat. And the cat's going to be pretty similar to the dog, right? Can someone walk me through this and give me I know, I think I want almost the same properties as the dog, but maybe we should mix it up a little bit. So I could use a little help. And what do we want to give our cat? Not a trick
Yeah,
question. It's going to need a name, right? And someone who hasn't maybe participated yet could help answer this for me. I know the cat's gonna have a name, a color, a sound, and in fact here, I'll go ahead. Well, I'll touch dog later. Should a cat have a breed?
Are we not supposed to raise our hand, or do we shout out, or how do you want us to answer? Because I was raising
Oh.
my hand. Yeah.
I apologize, guys. Thank you for reminding me. I need to be tracking that better. Yes, please do raise your hands. I've got that pulled up now so I can see it. So, sorry about that.
It's all good. What was the question?
I'm just looking for what properties do we want to give our cat when we create it, like that we should pass in here.
Color, sound, breed, name, location.
Well, I would say location is something, it's not really unique to a cat,
True.
right? I think that in our program, we might want to track that somewhere outside of the cat class. Depending on how we design the program, we could, but for
Right.
now, I want to kind of keep it specific to like the sort of intrinsic properties of the cat, if that makes sense.
That makes sense.
We can make it the same, an age.
Yeah, we can totally give it an age. Let's just give our cat something the dog doesn't have so that there's at least a little bit of a difference.
If it's nice or not.
I'm sorry,
Temperament. Yeah.
temperament. Yeah, and Brandon, thank you, and Gary, thank you as well. Yeah, we'll give the cat a temperament. Cats are temperamental, so like our cats move. And I'm just, in fact, gonna go ahead and copy this stuff because it is exactly the same. I do not really recommend copying and pasting for all of you, but I'm in part copying to kind of help prove the point because we're about to see how we can use some inheritance to reduce some duplication of code, specifically this stuff that we're copying and pasting. And let's go ahead and set the cat's temperament. In the interests of simplicity and time, I think I'm just going to leave us with the one getter and setter that we had. By the way, if you do Command Shift P in VS Code, it opens up what's called a command palette. And my favorite command is format document, though did not format that as well as it should have. And now I've got a cat. And our cat has an age, we give it a temperament and all that good stuff. And let's go ahead and I'll just name the cat Snuffles. I actually could use some help. What is a breed of cat?
British short hair.
Moon face.
Love it. British
Bingo.
Horehair. Moonface is up next. How do I spell Horehair?
Oh, short hair.
Oh, short hair. Thank you. British short hair, black. Meow. And I don't know, we'll make Snuffles 4, and Snuffles will be moody. I know my sister-in-law's cats are awesome, but they always can tell if I'm not paying attention to them, and then they'll come and sit on my laptop keyboard, especially if I'm doing work. And that seems to be like a critical skill for cats. And let me just go ahead and print Snuffles. And we get a reference to where this object lives in memory. Can someone remind me how I can do something so when we print Snuffles, we get some more useful
Put it-
information?
Put in list.
I'm sorry?
List it. List.
Not a list, but we want either a dunder string or a repr method. Yeah, and I'll go ahead and I'll make a repr method for us. And let's just return self.name, and I think maybe self.breed and self.color. In the interest of time, I'm not gonna write out the whole thing, but we could if we wanted to. And we'll do it for our dog as well. And now if I run my cat program again, now we've got some information about Snuffles, right? Okay, so this is all stuff that, we've kind of seen over the last couple days. And I'm catching up on the Zoom chats. And yes, Snuffles. Oh, I see that. Erica, thank you so much. I'll try to keep an eye in the Zoom chat. I do love Linux the cat. Let's just for the heck of it, let's go ahead and make Linux.
Yeah, I was gonna say instead of temperament, we could do lives or something like that.
Oh, that would have been brilliant. You know what? I'll just go ahead and add in lives now because that is a great idea. And I'm just gonna make the executive call here and both these cats get 9 lives. And this is something I'm gonna add a little to-do note to myself here. Because we should see the lives of our cats, but we'll actually come back to that to-do later when we kind of start talking maybe about polymorphism and stuff. All right, so we've got a cat, we've got a dog. You know, I've gone ahead and put these in an animals file. Let's see, where am I at the moment? If I navigate up a directory, let's maybe make a file named runner.py that can sort of be our main method. And can someone remind me, how do I import the cat and the dog class? Because what I want to do is I want to, you know, create Rover over here, and I want to create Snuffles and Linux over here. Right, so I've got, and you all can sort of see the directory structure over here. We've got the cat and the dog class defined in the animals directory. And at that same level as the animals directory, but not inside it, I've got the runner py. So how can I import my cat and dog class into this runner.py file?
Don't you just do import class dog from dog.py?
Close. That's, I think, is more like JavaScript syntax. And
Okay.
yeah,
From
let's raise our
import.
hand, folks. I know I wasn't kind of, I do kind of prefer the more conversational back and forth, but I think kind of like we were saying earlier, it'll help us. So I will try to be better about that. And Momo, yes, sir.
From import.
Yeah,
From, yeah, import from the folder, wherever the, yeah.
from animals.
Animal import. If we want to import the class dog, so it's gonna be dog.
Yeah, we're close here. I think there's one more thing we need, but let's go ahead and run it and see what it says. So we're close, but we get this import error. Cannot import dog from animals. So, and this is a good thing to review. These import statements are occurring essentially relative to where this runner.py file is. And the way Python sees the file system is it sort of sees this animals directory as, you could think of it as a module. But then inside of that are each of these files, cat and dog, and it sees those. And then we need to import dog from the dog file and cat from the cat file. And I'm actually gonna put these in alphabetical order just because that's my habit. And the way we do that in Python is we don't use a directory path. So you can see that the hierarchy is the same, but since kind of from Python's perspective, they're all modules, we do animals.cat and animals.dog, and then we can import these classes from, right, that dog file or that dog Python module out of the cat file as well. And let's see, I'm missing an argument for one of my cats, they need a life. If I look at my code, I see that that error is being thrown on line 12. So Linux must need a life, though Linux has a life. So there's probably something else I'm missing. And if I'm looking at the order of this, actually, I see that there are some differences in cat orders. And this points out the dangers of copying and pasting, because I did copy and paste this from Zoom. I need the name, I need the breed, I need the color. If someone just wants to throw the correct, Erica, if you want to throw the correct color for Linux in the Zoom chat, I'll update it. For the moment, Linux is going to be black. And now this next argument needs to be the sound. And this is where, by the way, I'm not going to turn these positional arguments into named arguments, right? Like if we do this, then breed becomes a named argument, and with named arguments, order doesn't matter as much. I'm not going to do that now, but this is a good example of once you get like this many arguments, it's not the worst thing to turn these into named arguments. And so now, got color, got sound, got age, got mood, I've got lives. I think we
You
should
said
be
the
good to go.
color is leopard.
I'm sorry?
You said the color is leopard.
Thank you. Literally a hybrid between a small leopard and a cat. Awesome. And you know, I'm not printing out a lot of stuff. And in fact, here, let's go ahead and let's print Snuffles and let's print Linux. And just for fun, we get some information there. So we've done a lot of good work, right? I've got, and I'll pull this up to the side just so we can kind of have this floating here, even though we're not doing a ton of this at the moment. We've got a dog class, we've got a cat class. They have a lot in common, right? A lot of similar properties. Cats have a temperament, cats have lives, dogs don't. The repr function for the cat is a little different because we might want to add lives to it. You know, they're gonna make different sounds, but we're gonna get there later. But this stuff is all the same. Our getter and setter for age and everything else. And so this is where inheritance comes in. We have a lot of repeated code. And so kind of where we're going next now is we're going to create a parent class. I'm actually going to name it pet, I think, instead of animal, for reasons that we'll see shortly. Or even better, I think I'll name it mammal, for reasons that we'll see a bit later. Because both of these animals are mammals. They're both pets. And we're going to use inheritance to reduce some of this work. And I think what I'll do is we'll create a pet class and let's see what that looks like. And I'll keep this open off to the side so that it's easy to see stuff. I think that'll be useful. And let's put this class in its own file as well. And I'll use dog as a reference. And let's create a pet class. And let's see what this looks like. So it's going to be very similar to the dog in a lot of ways. And in fact, I am going to copy and paste most of this over. Because there's nothing here, I think, that's unique to the dog breed. Some pets might not have a breed, right? But I think that that's, you know, most pets would have a species. So I think that's okay. And we can leave that as is for now. If we wanted to, we could change this to species later. And this is all this stuff should pretty much be universal to all pets. And so now we kind of get to the good part. And I'll just leave this up here off to the side. And what we can do over here is from, let's see here, pet, right? Because dog is in the animals directory. So the two dots, just like with cd ... I think I should be telling Python to look up a level, so to speak, from where this dog py is. Oh, and I don't need the ... pet because it's just the one module. It's not, pet is not inside a file. And we are going to have dog inherit everything from the pet class. And let me actually just run my code real quick. Make sure I haven't done anything silly. And I think it is, I may have my import path wrong here. So let me actually fix that real quick, because I think, let's see if that does it.
I think Chris has a question. He had his hand up for a long time.
Oh, thank you so much, Chris. I apologize. Yes, what's up?
Yes, it's okay. So the import statements that you did, since it's in the same folder or same yeah, folder, repo, whatever, do you have to say animal from animal import whatever the file that you're trying to import? Can you just
Over here
import
in the
that?
runner.py.
Yeah, or okay, using the runner. I was talking about dog and cat.
So I don't think we're gonna have to say animal, but I did put pet kind of on purpose outside of that animals directory.
Okay, okay. So you had it in two different. Okay.
Yeah,
Misread
exactly. But I did get that wrong just now, and I actually do need to fix that. And to be honest, I always get confused about this, and I think I'm just going to ask ChatGPT. Python module import relative path. Let's see how they tell us to do it. Make sure I have it right. Yeah, this stuff is getting. Yeah, this is all stuff we don't want to do. Let's see. Let's see if that works, actually. There we go. Okay, that does work. I apologize, folks. I think basically all of these paths are based off of where runner.py lives. So with dog, I believe that what's happening here is dog gets imported into runner.py, right? And then this is where all this code gets ran. So we want to give a path based off of runner.py. In essence, this is an absolute path sort of from, you could think of it as the project root, right? This main directory where I have my runner file. And Python relative paths are a bit of another thing for another day. So I should have the pet importing correctly here because I'm not getting errors, but we're not doing much with it yet, right? We still have all this duplicate stuff. Well, I can get rid of all of this because it's in the pet class that dog inherits from. I can get rid of repr. I can get rid of all of these. There is one thing I have to do, because if I go ahead and run this code, and let's comment out Snuffles for the moment. If I run this runner code, we should get an error. And indeed we do. Right, and it says it's inspecting an indented block. I could put pass in here, and we could run our runner code again, and we get another error. And this error is saying the dog has no attribute age. And inheritance aside, if this was just normal Python, the classes that we're familiar with, there's nothing happening in this constructor. Of course, nothing is working in runner py at the moment. Of course, if I try to get Rover's age, it's failing. So how do I use the constructor, the dunder init method here in this parent class that I'm inheriting from, right? Because that's really what I want to do, because this is doing all of the work now. And there's a special Python function really that we can call, and it's named super. And what this does is it gives us the parent class. So doing this, and let's just pass in, I believe it. I need to double check actually if we need to pass in self or not. Let me do a quick sanity check. Yep, and we don't, which is good. Passing in name breed, color, sound, age. Doing this is the same as, you know, maybe if we had done, well, we can't really do this, but this is what is happening. The init method of pet is being called. And so now, fingers crossed, when I run my code, I should not get an error. Right, because this super gives us access to the parent class, and then we call the parent classes dunder init method. And so this is the essence of inheritance right here, is I have a pet class. By putting in parentheses here, dog inherits from pet, and then inside dog's dunder init method, I can call the init method of the parent class, and thus I don't have to duplicate all this code. I can share logic between things. You know, we're going to add this to the cat in just a moment. So this is the essence of inheritance, and this is a good time to pause and check in and see what questions people have. And Erica, yes, I see you have your hand up.
So if you had like an extra, if you wanted to add more to it, you would put the self dot something else underneath the super, and the super would be just like the ones that are in the class pet, right?
Exactly. And in fact, let's go ahead and just do that right now with cat, which is where we're going next. That's a great question. Right, and we'll maybe come back to that. So a cat has temperament and lives, and we need to import, right? And because this all is getting run in come on, File Explorer. There we go. Sorry about that. Because runner py is sort of our main method, and where cat gets imported and runs all this code, we want this import path to be based off of that. So we say from pet import pet. We tell the cat class it's going to inherit from the pet class by putting this in parentheses. And then just like you were saying, Erica, we use super. And in fact, if I hover over it, we'll have a nice description here. Actually, it is not nearly as nice as I thought it would be. So we'll ignore the VS Code description. But super gives us the parent class. And it gives us access to the dunder init method. I believe, like, if we had class attributes, it would give us access to that as well. So it gives us a lot of stuff. And so we can call the init method of our parent class, which is pet, and pass in all of these same things. I don't have to pass in self, by the way. I did want to double check about that, but you know, because this, I believe it's because cat is the instance that we're creating. So self is the reference to that. I'm not 100%, but the main thing is we don't have to pass in self when we're using dunder init. And we're going to do name, breed, color, sound, and age. And then just like you were saying, Erica, here we have cat specific things. And now if I hop over to runner py, let's uncomment Snuffles and Linux. And let's go ahead and let's print. We'll see this stuff printed out. Just remember that we don't have the age and stuff in here. So let's make an F string. Let's say Snuffles cat info, and it's Snuffles temperament and you know, lives Snuffles lives. And let me adjust this a bit so it's a little easier to see. And let's do this for Linux as well. And now fingers crossed when I run this. Now we're really putting inheritance to work because we've got a cat and a dog that have slightly different things, but they both inherit from the pet class. Right? And I'll kind of just pull all of these up just so we can see it all in one spot. And I'll maybe just make the font size just a bit less because I think it's probably a bit much. So we've got pet. We've got dog. And we've got cat. And I realize this is cut off. So if this kind of layout isn't helping folks, please let me know. And let me check in on the Zoom chat and also X-ray questions. Cool. I don't see anything in X-ray questions. Erica, I saw you asking about super. Great question, and Connor threw a great answer in here. Super means over or above, and when we do inheritance, we have a super class or a parent class and a subclass or a child class. And so super gives us access to the parent class. And actually, let's just ask ChatGPT too and see if they have a good way to describe it. Yeah, ChatGPT's description is okay. I think this is the main thing. Super lets us refer to the parent class without explicitly having to name it. There's probably a little more going on under the hood there with Python, but that is, I would say, the main thing.
I have a question whenever you done.
Yes, sir.
Are you done?
Yes.
Okay, sorry. So if we're going to use all these classes, we have to state that we are importing something from somewhere for each one to use those methods, correct?
Probably yes. Like I could have put all of these in the same file.
Okay.
And you can, and often, you know, for simple things should, but I wanted to show this because as programs get bigger, it'll be easier to organize stuff this way.
And another thing, do you not see my hand? Is it not popping up on your end, or because I've been waiting for like a good little minute every time.
It does. I do need to watch it a bit better. I'm trying to kind of sort of cover a chunk and then pause and check in. So I need to do it a bit better, but also I'm trying to kind of cover a chunk of material and check in and see who has questions and stuff.
From there. Okay. So all right. So next time, so because you checked the chat and then I raised my hand as soon as you said you was going to check the chat and you still didn't see my hand. So I was just curious if you not seeing my hand or whatnot.
No, that's my bad. I apologize.
Okay.
Yeah, there should be a setting for you to hear like a little boop when the hand goes up.
Yeah, I thought I
your
had it
Zoom?
on, but I clearly don't.
Boop.
Yeah, I will try to do better. Please keep using the hands and please just keep telling me if I'm missing folks. Yeah, I do apologize about that. What other questions or things are on people's minds with inheritance as we've covered it thus far?
And Dustin has his hand up.
Oh yeah, Dustin, thank you.
I just wanted to see if there was like a recommended file naming or like how to organize it better, since we are gonna like what you're doing and importing, and if there's a smart way to do it, if you know, an easier way or just the best way.
Yeah, that's a good question. This way is a pretty good way. On a practical level, you know, cat and dog are pretty small. So I would probably start with them in the same file. But if I start having a bunch of stuff, then I might start making different files. Like one file per class is a pretty reasonable convention. Because like we might end up with 5 or 6 different animals, right? The truth is some people will say if we have like 6 different animals and these are small, they should all just be in a file named animals. I think other people would say have a directory with each class in its own file. I guess I would say have each class in its own file. So I think that's it's simple, it's straightforward, it's easy to follow. Yeah, there you'll see a bit of both, and it's a little pragmatic. But this is a pretty common organizational setup. Does that help a bit?
Yes, thank you.
Totally. Cool. Daniel, yes, sir.
So I'm looking at the class dog. You don't need a dunder string method to represent when you, I guess, call that instance of dog.
Great question. Dog inherits this dunder repr method from pet. And let's actually see this in action. And I'll close these out and we can look at it. So dog inherits not only all of these instance attributes, but also all of these instance methods. So if I go over here, let's go ahead and there's the cat stuff. I'll comment it out. Let's bring back the dog stuff. And we can see it in action. And in fact, let's go ahead and print Rover. And let me go ahead and run the runner. So, right, I can use a getter, a setter, neither of which are defined in the dog class, right? We ripped those out of the dog class. They're only defined here now in pet. And then when I print Rover, print uses this repr, dunder repr method from the pet class. So dog inherits all of these instance methods as well. And that's one of the huge benefits of inheritance.
Thank you.
Yeah, great question. And Dustin, I think I tackled your question, but I just want to double check. Perfect.
Yes, so I thought it automatically rolled. Thank you.
No, it is a little annoying because you have to kind of turn it on and turn it off. Yeah, so this is the essence of inheritance, and as you can see, it's super useful. There is a lot more ground for us to cover this morning because we're going to look at another way of designing object-oriented code, not using inheritance, called composition. We're going to look at polymorphism, and that might be a good one to touch on now briefly, and we'll dig into it more later after sort of the work period. And after the work period, we'll look at polymorphism. We'll look at how to use something called an abstract base class or an abstract method to kind of help define the shape of these sort of classes, these parent classes that inherit. And if we have time, we'll look a little bit at having multiple inheritance, which is less common, but totally possible, where say, you know, a dog is not only a pet, but also a mammal. But we'll kind of, I think, take a look at that one later. Let's see, I think we should. What else? I think, let me add a speak method. I think that'll be good to see. I could add a method named, you know, make sound to my pet. And we can return an F string. And, or even better, let's just return the sound. Right, and I'll make it an F string with an exclamation point or something. Or we'll just return the sound. And now over here in my runner, and I suppose we'll put this here so it's a little more interesting, because otherwise there's not a lot happening with this method. And let's do this here as well. And when I run my runner, right, Rover says bark, Linux says meow. And again, we can see how like inheritance can be really powerful. And even though we're using the same make sound method for both of our animals, how we can use these attributes to do different things. And in fact, maybe, you know, maybe we want to make a method named pet, like we're going to pet the pet. And this should maybe return an F string. And, you know, it should maybe say something like self name is happy. They've been petted. And we can pet Linux, and let's pet Rover as well. And Rover is happy they've been petted, and Linux is happy they've been petted. Except the only problem here is our cat probably shouldn't be very happy that they've been petted, right? Because cats have temperaments and they might not always be happy. So we actually are going to write a different pet method just for the cat. And let's maybe do something like if self.temperament equals, oh, happy. I know that this is not a very flexible if statement because there's so many different possible temperaments, but that's okay. And I believe what we should be able to do here is call the pet method from our parent. And otherwise, if our cat is not of a positive disposition and doesn't have a happy temperament, let's return and actually is not happy they've been petted. And let's see if this works. So let me let's bring this over here. And I apologize if there's too much screen jumping going on. And so we can test this out. Let's change Snuffles from moody to happy. And let's go ahead and let's comment out all this stuff that we don't need with the dogs. Let's pet Linux and Snuffles and see what happens. And then we can talk about this. So 3 is some print statement from something we don't need to care about. Rover's happy they've been petted. This makes sense, right? Dog.pet is using the pet method from not the dog class, but from its parent pet class. But for the cat, Snuffles is happy, so we use super to access the pet method on the parent class. But we have our own pet method here. And so this is called polymorphism because we have these two things. I can say dog.pet and cat.pet, but they behave differently. And this is also like the term is like method overriding or overwriting or method overloading because we're kind of overriding the name, right? Like these two methods have the same name, but this one that we define on the cat class takes precedence. And if our cat is not of a happy disposition, then it'll print out they're not happy that they've been petted.
Ding.
Thank you. And yes, Chris, yes, sir.
So question. So okay, I understand about cat and dog, but what is pet? Is that where all the can you go to the pet file? Okay.
The pet class right here.
Yes.
Yes, what about it?
So are we saying in here? So how does it? Where does it start? I guess like where does everything from start to finish? Like where does it? What file becomes first, and then what file like? Because everything's going to each other, correct?
Yeah,
Like dog is
totally.
going to pet. Okay.
Yeah.
Mhm.
I think if I'm understanding what you're saying, I think looking at it from the top with runner.py is probably the way to go. Let me walk through this, then let me know if this is kind of what was on your mind.
Gotcha.
So we've got this directory structure of, we can think of this essentially as the root directory for our project. I have runner.py right here. I have pet.py right here, which has the pet class. And then we have this directory animals right here that has the dog class and the cat class. Runner, the name runner is just sort of a convention. As our programs get bigger and more stuff lives in different files, we'll often have one file that actually kind of like runs the program and imports all the stuff. In JavaScript, it might be called app.js. Sometimes you see the file named main. Sometimes people will talk about a main method. And this is what starts our whole program, right? If I want to run this, I do Python runner.py to run my program. And because I use the dog class right here, and then over here I use the cat class, I have to import those classes into runner.py. And so since each of those lives inside this directory named animals, the way I do that in Python is I say from, and then this is not a file path, right? It's not, you know, it's not like animals slash, because Python doesn't see files, it thinks of it as what's called like a module. So we import modules, and this folder is effectively a module that is just holding other modules. So instead of, you know, if we were on the command line, it'd be like animals cat py. But instead of that, what we do is from animals cat import, and then the thing inside cat py that we want to get. And we do the same thing here for dog because we need to use it as well. And then if I go into the cat and the dog classes, because we need to use this pet class that we inherit, we need to import that as well. And this is where I need to, I think, do a little double checking to make sure I'm understanding Python correctly. And in fact, if you hover over pet, you can see it says module pet. So that's kind of how Python thinks about this. Remember that, like, this just defines the cat class. We create an instance of the cat class here in runner.py. And so I believe that's why this import path is the way it is, where it's like from pet.
Would you wanted to do that in cat class and then call it in runner? Would that be more like organized, or is that
You mean to like create the cat here, like Snuffles? Yeah. Usually not, because and that's a good question, because what happens is our classes are just going to keep getting bigger and more complex. And what you generally want is you want it to be easy to import this class into other places, because pet's a good example of this. We need to import pet into two different spots, right? We need to import it into cat py. We need to import it into dog py. So I don't, you know, I wouldn't want pet to be doing other stuff in here. And similarly, as our program gets bigger, maybe for whatever reason, maybe I have a test.py file where I need to create some cats as well. I would want to import the cat class into there. So it's pretty common that like you'll have your class definitions in one spot and then the code that you actually execute and run in another. Now, that said, if you all remember, when we were writing this and coding this as we were going, I definitely was doing, snuffles equals cat, and, I was writing code here and like running this file directly, because for me, that's a much easier and faster like development workflow. But then when it kind of got time to put stuff here in the runner, I cleaned it up a bit. And I did, this program is small enough that, realistically, we don't even need an animals director if we don't want one. Cat and dog could live in the same file. But I did want to make sure that we saw a little bit of project organization and structure and importing and exporting. Does that help answer your question, Chris? Because project structure I know is a big one, so I'm glad that you asked that.
Yes, it did. Thank you.
Absolutely. And let me catch up on the Zoom chat. Oh, Eric, thank you for sharing the module resolution Python link in the chat. I think that'll be useful. And for the assessment, we'll be giving you all kind of the structure that you should put your projects in, but you all will have to do some importing.
Bing.
Yes, sir. Connor.
Yeah, so could you tell us like the use case for inheritance and when to use it and when not to use it, and some pitfalls of using it too much?
I can, but I want to do that later when we talk about composition.
Okay.
You raise a really good point though, and we'll talk about this more later, folks, because I want to break now so you all can get some hands-on time with the coding assignment we have specifically about inheritance. But when we talk later about composition, we'll talk about when to use this and when not. And the short answer is, a good rule of thumb is it's sort of like the has a rule, like a cat is a pet. Or after the break, we're going to look at like cars and motorcycles. A car has an engine. So when we kind of look at cars and motorcycles, we're not going to use an inheritance. We're actually going to use what's called composition. The thing that you want to avoid, and we'll talk about it later, is like tons of layers of inheritance. Like cat inherits from pet, right? And let me make a split here. Let's put pet over here. And so as my code gets bigger, to really understand what's going on here, I really kind of have to have both these files open at once. Or even if they're in one file, have a split so I can see both these bits of code at the same time. What if pet inherited from, say, creature? Then all of a sudden, it becomes a lot more work and a lot more complicated to try and understand the behavior of the cat class. And so these like 3 levels of inheritance like this, for example, is when stuff starts to become unwieldy. Ooh, that was not what I meant to do. We will talk more about that with some more concrete examples. I just want to do it a bit later. But that is an excellent point. Let me go ahead and pull up the assignment so that we can take a look at it. Also check in to see if there's any other questions, and then we can get some hands-on time before we dive into part 2 to talk about composition and when to use inheritance or when not. And we'll also talk a bit more about polymorphism and stuff. So the assignment I'd like you all to get started on is the zoo assignment manager. And everyone can still see my screen, correct? Okay, awesome. And we're going to build a zoo, and we're going to use classes. And actually, as per your point, Connor, a good sign that inheritance might be the tool to use is when you're creating a program where things have a really clear hierarchy. That is often a sign that inheritance is a good tool. So we're going to want you to create an animal class, and we're telling you very specifically the instance attributes and the instance methods that the animal should have. We then want you to create a mammal class that will inherit from the animal class. And just like you saw me kind of like adding some extra stuff to the cat class. You're going to have to add a method to a mammal class for give live birth, and then continue on with a bird class and a reptile class. And so on and so forth, as we just kind of add more, where we just want you to practice creating classes and inheritance and creating all these different animals and having a sort of this hierarchy of animal classes and a zoo management system. We do have some tests for this. I would say please do try to write code to match the tests so that all tests should be passing. Obviously, if there's a problem with the test, then let us know. And once you have that done, if you want to go beyond, go for it. The tests here are really a tool, I think, to help keep you on track. So that's the plan for the next 40 minutes, and then we'll talk more about inheritance versus composition and some design principles and polymorphism. Yeah. Does that sound good to folks? And do folks have any questions, whether it's about the assignment or some of this OOP stuff that we want to talk about one last time before we break and get our hands dirty and cook up this recipe?
Bing.
Oh, thank you guys. Yes, I saw it just now. Momo.
Yeah, just the polymorphism. The polymorphism, like two classes sharing behavior, but everyone do it in different way, right?
Yes.
So how we gonna write it here again? The
Yeah.
code for this. Did you do it in the, did I miss it or no?
I sort of did. I want to go into it a bit more later, and I'm not gonna lie, I always get a little confused about a good polymorphism example, but we actually the speak method from the zoo assignment is actually a good example of it. Here, this pet method is a good example of polymorphism in that the goal is we want to be able to use the same method name, right? So that I can, in runner PY, I can say cat.pet or dog.pet, and I don't have to think about it, and I can have consistency, right? Especially if maybe I'm having other code manipulate my code. But the cat and the dog need to respond differently to how they've been petted. So here, the cat responds one way if they've been petted. That's unique to the cat, but all of the other pets right now, well, the dog right now will just respond the normal way with this pet. So this is an example of polymorphism in that we have two different methods with the same name, but the behavior is different. And I realize you're welcome. Yeah, it's a good question. I will kind of try to tighten up my explanation of that because I think it is a little confusing. But this covers the essence of it right here, like with pet, where I have a pet method for all the other pets and one for the cat, but they can behave differently and I can overload the method. And that way with all my animals, I can call the same method name when I'm writing code. You know, I could do something like if I had, you know, all pets equals Rover, Linux, Snuffles, or, you know, P in all pets, P.pet. This is why we want that method name pet to be the same. Because if I want to pet all of the animals in my house, I can write this loop to do it. But this way, the cat behaves differently when petted than the dog. All right, that is probably a good pause point right there. And by the way, the speak method on the zoo problem that you all are going to tackle now is also an example of polymorphism. All right, let me stop the recording and then we can dive. All right, so we learned about inheritance. We got our hands dirty. We started to talk a little bit about polymorphism. Let's talk a little bit more about polymorphism, and that will lead into talking a little bit too about using this tool called an abstract base class or an abstract method to help structure our code more. And there is this one explanation of polymorphism that I really like. And now I'm looking for where it is. So I'll share it with you all in a bit. But you know, the term itself, if we break it down, it's many forms. And I think this pet method is a great example where if I pull up pet and let's pull up dog. Or excuse me, cat. We have this pet method in many forms. We have it here for a cat, but we have it here differently for the pet. Or for example, to borrow the speak method from the zoo exercise that you all started. Let's see, we do have make sound. So we do have the make sound on both of them. Let's just lift the pet method from here for the time being. Actually, we'll just leave it there for the time being and just put it on dog, just to make the comparison a little more direct. So here we've got these two methods for the cat and for the dog. They're both named pet, right? Different methods, different forms. Same name. So our pet method can take different forms for our different classes, and that's the idea of polymorphism. But we keep kind of the same interface, right? So if I'm writing some code because I want to pet all the animals in my house, I can do that very easily, as I showed a bit earlier here. And that's the essential idea of polymorphism. It's a big word. The concept is a little fuzzy, but it's relatively straightforward, right? I can have one way of petting a dog and another way of petting a cat. But then by using the same method name, we can then write code that we can leverage for all of our animals. And that's the core idea. And I just want to check in to see if folks have any questions or thoughts around that. And now my hand is raised and I have to lower it. Okay, awesome. So let's build on this idea because, you know, we've got the cat and we have it petted one way, and we have the dog and something else happens if we pet the dog. And in fact, if we had a lizard or a bird, their reactions would all be different. So, you know, maybe I don't want this on the pet class at all. Maybe indeed, I just want to make sure that for each animal, they get petted in the way that they are expected. And that works too, right? We have the cat and we have the dog that have each of these methods. But, you know, let's say just for the sake of argument that I want to make sure that whenever I have a pet, I can pet the pet, even if it's a lizard or a bird, just for the sake of argument. So it'd be great if I could somehow use my code and Python help kind of enforce this structure for me. And often you'll hear the term interface. And when you hear the term interface, think about how you use something. Like, how do I drive a car? I've got the steering wheel to go left and right. I've got the brake. I've got the gas, unless it's a Tesla, in which case it's just the one pedal. That's the interface to my car. In a lot of ways, these instance attributes are the interface to the cat class. This is how we interact with the cat class to do stuff. Same with the dog class. So having all our pets sort of have a common interface can actually be really useful. There is a way to do this in Python and in object-oriented programming in general, and it's called an abstract class. Because right now, you know, if I wanted to, I could go ahead and let me just get rid of this stuff because I don't think we need that. And let me just check in real quick. Is screen font size good? Is code readability good for everyone? Okay, awesome. Perfect. So, you know, if I wanted to right now, I could create an instance of my pet class, though I need to import it, right? From pet import pet. And let's see, we need to give it a name. And a terrible name for a pet, but that's okay. And this pet is just some sort of creature because it's not a dog or a cat. We don't know what it is yet. It is blue. It says hello, and it is 4 years old. And let me go ahead and run my code. And we have this pet named Richard. So the question is, do I ever actually want to create an instance of the pet class? Or do I always want to have some other class inherit pet for cat or dog or bird or lizard, right? And in a lot of ways, this is a design decision. But it's a common design decision to have something called an abstract class, where the idea is I'm never actually gonna create directly an instance of the pet class. Like Richard needs to be a dog or a cat, or I need to create a bird class or a lizard class, or you know, an owl class. I was trying to think of something Harry Potter themed, and I can only think of the owl. I don't actually want to use the pet class directly, but I do want to make sure that all of the pets, all of the different classes that inherit from pet share certain qualities. So Python has something called an abstract based class as part of their standard library. And I believe all I have to do is import ABC. Let me, in fact, double check that right now to make sure I have that right. To import our abstract base class and use it. And indeed, it is slightly different because we are importing from the abstract base class module a class named capital ABC. And note that VS Code here is giving us some hints about this. If we hover over it, it tells us that this is a class. It's a helper class to provide a standard way to create an abstract base class using inheritance. So there's probably some other stuff in this module tool, maybe some other helper methods, or I don't know what exactly. But so, or maybe this is the only thing, but we have to import it from here. And so when I want to use this, first of all, I apologize because I'm actually in dog py and we want to be in pet. And we're going to use this here. Just like any other kind of inheritance, I'm going to have pet inherit from my abstract base class. And all of this stuff can stay the same, but now I think we should get a failure if we try to actually create a pet. And I guess it actually still works. I'm a little surprised, to be honest. However, the idea is when you are using an abstract base class, you shouldn't be using it directly. So we actually don't want to be doing this anymore. And what I actually think I want to do, because I know that I want this pet method on the cat, I want the pet method on the dog, is I actually want to create an abstract method And apologies, let me make sure I get my name right here. Oh, I see. We have to, let's try it this way. We actually have to import the decorator from that same ABC module. That's probably the easiest way to do it. I'm going to go ahead and make a method named pet. And the kind of interesting thing about this method is it's not going to actually do anything. And you actually never want an abstract method to do anything because it's the job of the class that is going to inherit pet to actually do something with this method. And in fact, let's see, let's comment out Rover being petted. So I don't want to pet the dog, but if we didn't have this pet method on dog, let's see what happens when we run our code now. We get a very interesting error. Type error. Can't instantiate abstract class dog with abstract method pet. And what this is saying is because dog inherits from pet, and because pet is now an abstract base class with this abstract method named pet, we have to define a method named pet on dog. And that's the cool thing about an abstract method. Like now, every class that inherits from pet has to have this abstract method. And so if we uncomment this, our error should go away. And let's see, what did we not like? Oh, this is being thrown by the other code that needs to go away now because we don't want to be using the pet class directly anyway. And now the code runs, and indeed, just the same way I can pet the cats, Linux, and Snuffles, I can pet the dog Rover. Right, so this is really useful because it helps us organize our code. It helps us enforce consistency. And as a programmer, if I'm looking at this and I'm looking at the pet class and I need to create a new pet, I know I have to make a method named pet because I see here that it's an abstract method. You don't need to go overboard with this stuff. It's very easy to get very complicated very fast, but this is a great tool in the toolbox. The abstract base class and the abstract method are not on the assessment coming up this weekend. They are really important to know. I do encourage you all to use them. We actually need to build out more assignments around them. And when we get into Django, you will be using code that uses those things. So let me pause and check in and see if folks have questions or what's on people's minds.
Yeah, I need. Can you give us example?
Another example of an abstract method.
Yeah, over the cat and the dog and something else.
Yeah, let's come up with another one that we want to add for cats and dogs. Can someone help me out and suggest something that we think a method that all pets should have?
Life.
I'm sorry?
I don't know. Do we need to do another variable like to compare both? Oh, tail length. Someone said in the Zoom chat, but I was saying if they were alive or something.
Oh, like is alive?
Yeah.
I like it. Let's run with it. Sleep, awake. I like it too. Let's run with both of those. I think both of those are awesome. So let's go ahead and let's modify the pet class. Let's have all the pets be alive by default. I think that makes sense to people. And let's have them all be awake by default. So let's do alive equals true, awake equals true. So not only are these optional arguments, but both of these will be the default values for alive and awake. And let's go ahead and do self alive equals alive and self awake equals awake. And you know, these actually, I wonder if we should make these getters or setters. But I'm not going to because we want to use them to show abstract methods. So we'll let that be as it is. So now we have these properties, but we need to be able
Adam,
to.
I'm sorry for interrupting. Can we add one more bit? Like we have 3, we're gonna abstract over 3 classes.
Oh, you mean another pet as well as cat and dog? Yeah, absolutely.
That would, yeah.
Okay.
Thank you.
Let's do a lizard. And actually we'll come back to lizard in a little bit. So let me go ahead and let's just copy this. And I'll make a new lizard real quick. And we'll put that there. We import the pet. We've got the lizard. And we've got our lizard. And the lizard, so this is a good example of polymorphism, right? The lizard is going to not be very happy when it's petted, and it's going to hiss. Awesome. And so now our pet abstract class, we're adding alive and awake, and we probably want some methods. Someone had said, you know, we should check if it is alive. So let's maybe make a, how about go to sleep method, right? And let's make this an abstract method. You know, the only thing I'll say about going to sleep and waking up is if we were actually building this program out, I'm not sure if there's actual, it might actually make sense to have this just be a normal method on the pet class, because I'm not sure if there's dramatically different behavior between each animal, but we can absolutely come up with a way to make it happen. Let's make an abstract method like how about wake up? And an abstract method, unfortunately, it's just going to be named dies. Right, and we'll figure out what to do with all of these in a bit. Let's run our code. There's going to be a couple tweaks we'll have to make because now that we've added these additional properties, we'll have to do more things. And then we'll build this out. So I wrote my code. I get this great error message like we were talking about. Can't instantiate abstract class dog with abstract method dies, go to sleep and wake up because they don't exist yet for the dog. And let's go ahead and create a lizard, right? Now that we have a lizard, animals, lizard, import lizard. And let's have our lizard. I don't know, we had Richard, which I'm just using because it rhymes with lizard. So we'll have Richard the lizard. Richard can be a gecko, which might actually be some sort of amphibian. Let's just, the snake is properly a lizard. Snake color, right? 1 year old, and I think that's everything we need for Richard. To test, let's print Richard to make sure Richard prints, and I don't have any errors in my lizard code. And indeed, I do have an error because I made a typo on line 3, probably in importing lizard.
We need hiss, the sound.
What's that?
We don't need to add the sound to be.
Oh, we totally do need to add a sound. Thank you. Yes. And we'll throw in hiss. And let's see what we're missing. So let me, I'm not even getting to my lizard code, right? We're getting our abstract class dog error. Let me move Richard up in the rotation. Though we'll actually see the same issue with Richard the lizard, right? Is Richard doesn't have these abstract classes yet either. So let's go ahead and create these methods for Richard the lizard. And so Richard is going to need to die. And anyone want to tell me what our lizard should do when they die? How about something like hurls into a ball, right? I don't want to get too macabre. Richard the lizard is going to have to go to sleep. Any thoughts? What do we want our lizard to do when it sleeps? How about hurls into a ball? And then when it wakes up, it's going to have to
Return, stand on head, still.
yeah, we'll just have the lizard wiggle around when it wakes up. Right? And so now I've got these methods for my lizard, and if I run my code, can't instantiate abstract class lizard with method wakes up. And it looks like I had wakes here and wake here, so that's an easy fix. That's just a typo. And now if I run my code, we're moving on to the dog. The lizard is good to go. So let's go ahead. And so we can see here the abstract methods in action, right? It enforces structure on all of these classes that inherit from pet. Owner watches old Yeller. When he goes to sleep, curls into a ball. Dog will also curl into a ball. Finds owner and licks face. And now if I run my code, can anyone tell me what error am I gonna see next when I run my code down? Any guesses? Well,
Is it gonna be the
hopefully,
same,
oh, Polly, please.
is it gonna be the same error that we got for the dog? Because
I
we're
think
also
so.
missing it for a cat.
Yeah, that's my hope, unless I got something wrong. And indeed, we have the exact same thing for the cat. Right? And so let's go ahead and let's add these methods to our cat. And so hopefully as you all are seeing this, you're like, oh, this isn't so bad. This is pretty straightforward, and it should be. Cats, when they're sick, they don't like people to know, so the cat is gonna find somewhere to hide before it passes away. The cat is gonna find somewhere to hide when it goes to sleep. And the cat, when it wakes up, is going to meow until the owner feeds it. Because I feel like whenever I cat sit, cat loves to help me wake up in the morning. I mean, I guess the dog does as well. And now we should be able to run our code and everything's working. And let's just to test it all out that there aren't any problems. Let's just, do a couple things. We can do rover, wake up. What I didn't do and what we should probably do is awake should really be is awake. Especially for Boolean variables holding state. It's kind of a good idea if you can for stuff like this to stick a verb in front of it. And then what we need to do, is can we add this to the abstract method? I believe we actually have to add this to each of the individual methods. I have to check. I'm not sure if with an abstract method, if we can do like self is awake equals false.
I have a question.
Yes, sir.
So for abstract methods, that we have to have the same methods for each file except for runner.
Correct.
Okay.
Well, for each of these files, because each of these classes inherits from pets. Right? Because pet is now my abstract class with this abstract, with all these abstract methods. Because cat inherits from pet, that's why all this stuff gets applied to the cat. And same with the dog and the lizard. If the lizard didn't inherit from pet, then we'd be fine. We wouldn't need any of these. Does that help to answer your question?
I think I'm more confused. So pet is where everything is. Everybody's using pet.
Correct.
That makes sense. But like I said, I see the method dies and cat, and I want to say dog and lizard in the same place and pet. So yeah, so you gotta have the same method in each file except for runner, because runner just calls it, correct?
Right. Exactly.
Okay.
Exactly. And if I went ahead and got rid of this abstract method decorator,
Okay.
then all of these other classes would not need to have dies. Like I could get rid, whether I have it here, like if I get rid of dies now from cat and run our code, we're not going to get an error. Although we did get an error for a different reason.
Gotcha.
Yeah, which is the problem with changing code on the fly. To talk about it is one thing impacts another. But the reason that all these methods need to be here is because we've used this abstract method decorator here on pet to say, hey, this method has to exist for anything that inherits pet.
Okay. Gotcha.
Yeah. And let me see if I can't fix my error. In fact, so we can see this in the code. And let's see what this is telling me. And it takes exactly one argument, the argument to initialize. I'm honestly just gonna maybe comment Richard the lizard out for the moment, because I don't want to. Well, let's see if we can't fix this real quick, because actually this is a good one to see. So object init takes exactly one argument, the one to initialize. We've got name, we've got the breed, we've got the color, we've got the sound, we've got the age. So that all makes sense. Name, breed, color, sound, age. If I look in lizard.py, name, breed, color, sound, age, name, breed, color, sound, age. Yeah, I'll have to come back to Richard the lizard to fix him in just a minute. To go back to your question though, I think with Richard gone, we should be able to play with the other code a bit more easily. So right, we saw with the dog, if I comment out this dies method, we get this error. And the wording of this error is kind of backwards, but what it's telling us is because dog inherits from pet, and because pet has an abstract method named dies, dog has to have an abstract method named dies. If I take away that abstract method decorator, that error goes away, right? And whether we have a method named dies here on pet or not, doesn't matter. Does that help as well?
So, abstract. Yeah. Okay. So the point of the abstract method. So whatever action you wanted to do to go to, is it called the parent class? Would this be the pet? Will be the parent class?
Yeah,
Correct?
exactly.
Okay.
Exactly.
So what if so pet is acting like the action. What if dog has another action and you want to do another file? Would abstract, so that's why we're doing abstracts to know which function to use for each file? Is that the purpose of abstract methods?
Close, very close. We do abstract so we know that for all of our pets, they have to have this action.
Gotcha.
Because, yeah, like, because I'm going to make a bunch of different pets and I want to make it a rule that every pet has to have these actions, these methods. And if they don't, Python will throw an error and complain. And the reason we do that is so that our code can be more organized and consistent. So again, if you think of the Zoo Manager program, if we were writing, like SimCity or The Sims, but for a zoo, and we wanted to wake up all the animals in the zoo, it's really nice if every animal has the same method named wake up.
I think, Adam, if you write this in Runner, this example, okay, the thing that you want to go over all the animals, okay, in one example, that will explain it to, will explain the abstraction or the abstract method to Chris.
I may need to come back to that later. I apologize because I do want to make sure that we have enough time to talk about composition as well. But I'd be more than happy to do that at the end of class. And Brandon, I see you have a question as well, sir. And then I do want to move on to composition, though, as I said, I'm more than down to chat about this a bit more when we wrap.
I just had a question about the abstract method and class pet. Would you ever put anything inside there except for pass? I assume not.
I don't think so. Let me actually double check that. Because I'm actually not 100% certain. I need to double check if we can. I don't think we can. We can test it out real quick by right here and go to sleep. We can just do, instead of pass, let's do, yeah, I don't think we ever would, because
I don't see a purpose, but I didn't know if there was one.
yeah, the purpose would be shared behavior, right? Like every animal, when it goes to sleep, we want to set is awake to false.
It would inherit whatever is in go to sleep in cat go to sleep and dog go to sleep methods. It would inherit self that awake is false, or yes or no.
I don't think it inherits. I need to double check, but I'm pretty sure, because, and also we'd have to kind of go through, we'd have to do sort of, I think, like super would go to sleep, which wouldn't make sense. Yeah, I'm 99% sure the answer is no.
Okay, thank you.
Yeah, good question. And let me double check that one. And I'll make sure to follow up on that, because I actually did want to double check that, but in general, no. And so in fact, one of the downsides with go to sleep and wake up, in particular being abstract methods, is that I have to manually set self is awake. It's true. Yeah, let me confirm that, but no, I'm pretty sure. In other languages, there's something called an interface, which looks a lot like this, except you don't write really any logic for anything. And that's very much what the abstract method is borrowing from. Let me catch up on the Zoom chat and X-ray questions real quick, and then we'll dive into talking about an composition. Connor has some good advice of things to be thoughtful of as you write more and more object-oriented code. And Erica, I see you're saying this seems like another way to control subclasses using a parent class. Like if there's a character class in a game, And you would have abstract methods for attack and defend for like a rogue or a warrior, and that's exactly it. You hit the nail on the head, and actually that's a great example to use. If you all think about like making a game and you've got different characters and you've got a rogue class and a warrior class, and you want to make sure that they all have like an attack method, you could have a character class and this abstract method for attack and defend and so on. Okay, let's talk about composition. And oh, and let me double check X-ray questions real quick. My apologies. Cool. All right, let's talk about composition. And let me go ahead and close these out. And I'll just make another directory and we'll put all our stuff in there. So I'm going to make a directory name composition, because we're going to use another analogy here. We're going to build some other things. We're going to do like cars and engines and stuff. And let's go into the composition directory. And so this is where we're going to be doing most of our work. And we're going to want, let's just make a runner.py. And let's just make like a car.py and motorcycle.py. And I think that should be enough to get us started. So we've talked about inheritance, and we've talked a bit about when to use it. And let me actually just very quickly, I think, summarize that. And I'm just going to pull up our curriculum so I can kind of highlight the highlights, so to speak. And that will set the stage for talking about composition, which is another way to organize stuff. So when we're using inheritance, thinking about the single responsibility principle of trying to have like classes be specialized and having more specialized child and parent classes, as is mentioned here, you know, we have one layer of inheritance, right, with cat and pet. If we start to have like 2 or 3 layers, like if pet inherits from like living being, which inherits from thing that exists, and we try to come up with a really fancy ontology, if you really need to, then inheritance is great for that. But often that actually ends up with code that's very confusing, and it's difficult to change it, because if you change one thing that's like 3 layers deep in the inheritance chain, it changes a ton of other stuff. The benefits are modularity, right? Consistency, like we just saw with abstract classes and an abstract method, and reusability. Composition, we're going to talk about this in a minute. And in fact, we're going to use this example that I'll kind of give a little bit of a preview here for. And I think maybe I'll just put everything in one file, in fact, for simplicity. But inheritance, if composition has a relationship, a car has an engine, a car has wheels, a motorcycle has an engine, a motorcycle has wheels, then inheritance is a relationship, right? Like a dog is a pet, a cat is a mammal, a lizard is a pet, or you know, a parakeet is a bird if we had a bird class. And so when you're thinking about composition versus inheritance, if you think about, is the relationship has or is, that can help. And let's build out some stuff with composition to see it in action and make this example real. Because I'm going to make a car, and let's just put everything in here to get started. And if we need to, I'll break it into other files, because I don't want to have it be too crazy. And actually give me just a moment here to pull up my guide code. So we're going to have a car. And we're going to have a motorcycle. And I'm gonna go fix that red squiggly up at the top, because I needed the colon, and I'm gonna fix the red squiggly here, because if I have an empty method, Python needs pass, otherwise it gets confused. And we want the car and the motorcycle to have a lot of same behaviors, but I don't want to use inheritance. We're going to create some other classes and do composition. So, you know, what's the stuff that we want in common here? Well, car has engine. Car's got an engine. A motorcycle has an engine.
Both
And
has
a
wheels.
car has wheels, and a motorcycle has wheels. Give me just a minute or two, folks. I'd like to code this out, and then we'll pause and discuss.
They also have horns.
They also have what?
Horns. Motorcycles and cars have horns.
That's true. I don't know if there's enough behavior that I can put into like a horn, like
Honk,
I
honk.
don't,
to
I don't think it
justify a
can work
class.
this one.
Yeah, but we can both have them. We can both have them. Like, this is actually a great example. We're not using inheritance, but we can think of this as polymorphism very much. Right? Even if we're not using inheritance, we probably having the names being the same is good. I like the horn idea. I think I'm just gonna go with. Yeah, we can do a horn. I'm gonna go with radio, just because I want things that are a little more substantial, because I'm gonna create classes based off of that. But I like where you're coming from. Because where we're going with this, and let me go ahead and just do a split so that we can see both at the same time, is let's make an engine class. Right? And what can an engine do? It can start and it can stop. It can do a lot more than that, but I think that's a good starting point. And we're going to make a wheels class. And I'm not putting a lot in the constructor. There is stuff that we could add in this thunder init method, but we don't need a ton right now. In the wheels, I'm going to keep it super simple. The wheels rotate. You know, we could do rotate left and rotate right, but we'll do it later. The radio I'll come back to because I want to get rolling with what we have. So we've seen inheritance. Inheritance isn't quite right for this scenario, right? Like a car has an engine, a motorcycle has an engine. It wouldn't make sense for the car to inherit from the engine class. You know, we could think about, say, different kinds of wheels. Maybe we want to make a motorcycle wheel class and a car wheel class because they are different. And you know, a motorcycle wheel is a wheel, or a car engine versus a motorcycle engine, right? A car engine is an engine. So if we want to play with inheritance, we can. But to demonstrate the technique of composition, let's go ahead and roll with this. And what I'm actually just going to do is self.engine equals engine. And actually, I should probably make sure that I define these classes at the top of my file. Just for simplicity, if nothing else, since we're using them. So I'm going to go ahead and put those there, and we'll leave them there. And over here, we'll scroll back to our car and our engine. So my car is going to have an engine, and my car is going to have some wheels. And I'm going to use list comprehension to build the wheels of the car. Oh, I see in the Zoom chat controls. Controls is also a good idea for cars and motorcycles. If we have time, we can play with those as well. These are just sort of the ones I had set up that I think are straightforward and wheels and engines are hefty enough for us to play with classes. So let's use some Python list comprehension to create 4 instances of the wheel class. Right, and this for loop, for in range, iterates over, and in fact, I want to make the wheel class singular, not plural. That's why I'm getting this red squiggly here. Name is not defined. Because this class, indeed, each instance represents a single wheel. And we've got a for in range, and it's just a convention. If you need a variable that you're not actually really going to use for anything, name the variable underscore, and that's how programmers know we don't need to care about this variable. And this will create a list that has 4 wheels in it. And then for my motorcycle, we're going to do something really similar. I need to remove pass because that's the block. The engine is pretty much the same. And then for wheels, well, a motorcycle only has 2 wheels. So we'll do wheel for in range 2. And now I've got a car and I've got a motorcycle, and the car has wheels and the engine has wheels, and we can start to do things, right? We can start the engine of the car, we can start the engine of the motorcycle, and we can turn the wheels of the car and the motorcycle. And let's add a couple methods to do these things just to see what it looks like. Self.engine.start, right? Because this instance attribute holds an instance of the engine class. And in fact, our motorcycle is going to be exactly the same. For wheels, we can get a little fancier. We can, I'm just going to use rotate, even though in some ways turn would make more sense. We can rotate the wheels of the car, right? We can turn them. And in fact, let's rotate the front 2 wheels of the car. Let's say that this car is going to be a front wheel drive. This rotate message returns a little, this rotate method returns a little message. So I'm just going to write some really straightforward code to capture that message and then return it. And let's do self.wheels sub 0.rotate, right? Let's get the first wheel in the list and rotate it. Let's get the second wheel in the list and rotate it. And then let's just return a message saying, wheel 0. And the messages are going to be the same, but this way at least they're there. Wheel 1, message 2. And here's another example of polymorphism in that both the car and the motorcycle rotate their wheels, but they do so in different ways, right? Because the motorcycle only rotates the front wheel. And so I'll just grab that message, self wheels sub 0 rotate, and we'll return that message. And I think we'll do the F string again, and we'll say wheel 0 message. And so now, I probably should write a runner py, and then we would import and use this. And actually, if we were to do that, it would look something like this. I've put everything in car for now for simplicity. So if that causes confusion, I apologize. But so, from car, import car, motorcycle, right? And let's say my car equals car, my moto equals motorcycle. And it would help if I spelled motorcycle right. Let me kind of use the VS Code hover. I think we're good there. And let's just print.
Motorcycle needs to be changed on line 46, left-hand side.
Oh, thank you so much. I was wondering about that because I didn't see a red squiggly. Perfect. And let's do the same thing for the moto. And let's run this code just to make sure there aren't any errors and see our code in action. And indeed, it looks like I do have an error. Let's see what this is. I see that it's on line 58 in my motorcycle code. Motorcycle object has no attribute wheels. So I do this list comprehension here. So I'm not quite sure what's causing that. Let me make sure the car is good, because I kind of copied and pasted that code. And if it works for the car, but not the motorcycle, perfect. Then this tells me I probably have a silly typo lurking somewhere. So let's debug this really easily. Let's right here, let's just print my moto.wheels. This probably will fail, right? Because the last error message said, hey, there is no property wheels. But let's see what's going on. So I probably just spelled something wrong. And indeed, if I look here at my dunder init method, I have the 2 underscores up front, but not the other 2. So this is actually kind of a tricky error to track down, because the error message, it tells me where the problem starts, but it doesn't give me a lot of information about the cause. So the way that I debugged this was I simplified, right? I'm not even going to worry about rotate. Let's just see if we can create a motorcycle and if it has an empty list. Because, you know, we've been on Zoom a long time. We've been writing code all morning. Like, my eyes are tired. You know, my brain's been looking at code a lot. Like, if that had failed, my next debugging step would have been that. I just comment and get rid of code until the problem goes away. And then I add it in 1 bit at a time until I see where the error is. And that's a great way to debug. And it also helps you focus in the right spot. And that's how I was able to see, hey, I just misspelled my dunder init method. Which, frankly, I wish VS Code would have given me a red squiggly for, but apparently it isn't that advanced. And now this rotate method, fingers crossed, should work for us. Awesome. So I know I've been going on for a bit there. And we are at time, but I do want to pause and check in and see what questions folks have around. Let's start with around composition and what we just coded up. And then if there's other things that people want to review, we can do that as well. So let me take a quick look at the Zoom chat and the questions channel. And I'm not seeing too much there, so let me check in. What's on people's minds? What questions do you have around composition? What would you like to review with it?
I have a question.
Yes, sir.
Where is the will method at in your code? Because it prints out will rotates. So is there a string in that method that says wills rotates? Or
Yes, there is.
Oh, right there. Okay. I was just making sure.
Yeah, no worries at all. I know, especially over Zoom and with the split screens and stuff, it can just be a lot of information. But yeah, you pretty much hit the nail on the head. And there's a lot of interesting stuff we could actually do with the wheels, right? Like, we could have it be more specific. We could name the wheels. So actually, I think there's a lot of interesting things. Like, I could keep track inside the wheel if it's rotated or not. You know, if we had, like, self is like rotated, or is it rotated to the left or to the right? We could put all of that inside the wheel class and keep track of that. Right? If we had like a direction, and then maybe, self rotated in direction equals direction. And then we could like track for each individual wheel what its state is, right? If we were, if you think about the beginnings of making a game or simulating something. What other questions do folks have around composition or things maybe to review from this code?
Yeah, can you correct me if I'm wrong? So the composition here in this case will be the engine and the wheel?
Exactly.
Thank
exactly.
you.
Yep. Yep, and in fact, another way we could have done this is maybe for some reason we want to pass engine in as an argument to the car. And over here, maybe we want to, car create a new instance of the engine. Right, I'd have to import it. If we wanted to if we wanted to maybe add more stuff to the engine, maybe then actually we don't want to create the instance of the engine inside the car. We want to pass the engine instance in as an argument to our dunder init method. That's another technique for composition as well.
Okay, I see Connor said it's preferred using the composition than the inherent. Why is preferred?
Yeah, great question. And I agree as well. As a general rule, preferring composition over inheritance is a good rule. I will say for the assignments this week and the assessment, we will be telling you very specifically to use inheritance sometimes because we want you all to practice it. That said, using composition over inheritance, not always, but in general, is preferred because it's more flexible. Sometimes you have very direct hierarchies, and with pets and lizards and birds, it's not actually too bad. But inheritance is super cool, and everyone loves it when you first learn about it, and everyone kind of goes to town when you're learning about it, and you should. And then as you write more code over time and then have to maintain the code or read other people's code, you realize very quickly, if I have 4 layers of inheritance and I have to dig through 4 or 5 separate big classes to understand what's going on, and if I change one and it affects all these others, it becomes a lot more difficult to maintain good separation in your code. The idea of separation of concerns is I can change one thing without it affecting other stuff, right? I should be able to change my car class without it breaking my motorcycle class. And the power of inheritance is all the animals, all the pets inherit from the pet class. The downside is I change the pet class and it changes everything, right? Which is a double-edged sword. It can be good and bad. And Connor, I don't know if you have any thoughts that you want to add to that as well about sort of as a general rule, why, if you're not sure, try out composition over inheritance.
Yeah, so the way I like to think about it is in terms of coupling. So coupling, it just means you're putting 2 things together at once. So an example of coupling is like Apple computers. Apple computers, they have everything all in one, and you can't go in there and you can't change it. But say some other kind of computer, you can just get individual components that are independent of each other, and you can just put it together and build it. And so it's more modular. So modular is the opposite of coupling. So inheritance is probably the highest level of coupling possible whenever it comes to OOP code. Composition has loose coupling, which is better than super tight coupling. And so in general, that's why inheritance is less flexible and it's harder to maintain. It's due to coupling.
Yeah, that's a great way to break it down. The only thing I would add to that is, all of these rules are guidelines. There are times when inheritance is a good fit as well. There's not one perfect way to do it, but you will see, especially if you Google Stack Overflow composition versus inheritance, you'll see a lot of folks talking about those same things and preferring composition. Inheritance is very powerful and so should be used sparingly. We're going to have you use it a lot this week and on the assessment so you can learn it, but you'll kind of see as you further get into the course. How are people feeling about composition and everything that we've covered? I would love just sort of a gut check from folks, like a thumbs up, a thumbs down, like a sun emoji, a rain emoji, just to kind of see how people are feeling and where you're at with the material.
Adam, I'm sorry, can you correct me if I'm wrong? So based on what Connor said, the inherit, it happened vertical, right?
Let's,
And the composition, it happened like horizontal.
yes.
That's why it's more flexible. It take no need to everything to inherit. That what he meant?
Yes, that's essentially correct. Let's talk about it a bit more when we wrap up. I think, which I'm about to do. Thank you, folks. I'm seeing some thumbs up. I'm seeing some maybes. I can see maybe it's just been a long morning. Let me go ahead and stop the recording, and then we can just kind of look at the assignments and stuff.